Welcome to the Algebra 2 Structure and Method textbook series. This lesson is from Chapter 10, Section 5. Our topic today is the laws of logarithms. So as I mentioned today, you're going to learn how to apply the basic properties of logarithms. Before you begin, you should know how to use the laws of exponents with integer and rational exponents and simplify radical expressions. Let's get started. Let's get warmed up by reviewing the laws of exponents. Complete each of the following and restart the video when you're ready to check your answers. I will display my answers now. Okay, now, if you didn't remember any of these, that's okay. I would just make sure to keep them handy during the lesson because you're going to need them. The rules of exponents can be used to derive three basic laws of logarithms. If we have b as our base and m and n are positive numbers, the following rules apply. First, the logarithm of a product is the same as the sum of the logarithms of the factors. This is called the product property. Second, the logarithm of the quotient is the same as the difference of the logarithms of the factors. This is called the quotient property. And finally, the logarithm of a number raised to a power is the same as the power coming down as the coefficient times the log. These three laws can easily be used to expand or condense a logarithmic expression. So if you want to expand, you go from the left side to the right side. If you want to condense, you go from the right side to the left side. Let's start with some examples. So for our first example, we need to express log base 6 m squared n cubed in terms of log base 6m and log base 6n. So this is an expansion problem, and we need to break the expression down further. First, I see that m squared and n cubed are being multiplied by each other, so I'm going to use the product property, split them up, and write them as a sum. Then I see that both terms have exponents, so I'm going to drop those down in front using the power property. And we can't really expand anymore, so we're done. Express log base 2 of the square root of m over n to the fifth in terms of log 2m and log 2n. This is really similar to the last example in that we need to expand the expression with some small tweaks. So first of all, I notice that I have a radical covering everything, so I'm going to change that to exponential form. Now, once my radical is in my exponent, I can drop the power 1/2 down in front. Okay, it becomes my coefficient. And inside of my logarithm, I have a fraction, which means I'm going to use the quotient property to split it into a difference. Finally, I still have that 5 on my power on my n, so I'm going to drop that down using power property. In example 3a, we're asked to express this as a single logarithm. So now in this case, we're condensing instead of expanding. So I see the 3 in front of, see the 3 as my coefficient in front of the log base 10q. I'm going to pull that up to the top as a power. Okay, now I see that I'm adding two logarithms, so I'm going to use the product property to bring them together. Our final answer is log 10 pq cubed. In example 3b, again, we're asked to condense an expression. I noticed first that there are 2 and 4 as the coefficients, so I'm going to pull those up as powers. Okay, then next I'm going to use the fact that it's a difference of the same log of the log with the same base to make a quotient. And my final answer is log 10 p to the 4th over q squared. Example 4 combines expansion and substitution with actual logarithmic values. So we're given the value of log 2 and log 3, and we're asked to find log base 10 of 18. So first, I'm going to write 18 as the product of primes. That's 2 times 3 squared. Then I'm going to split them up using the product property. Then I'm going to drop the power down in front. And then I'm going to substitute my value. So log 10, log 2 is 0.3. And log 3 is 0.48. I substitute and simplify to get 1.26 as my final answer. We're going to do another one. Same starter and same goal. So first we can start with the quotient property and split the 20 and the 3 into a difference. Next, I'm going to rewrite 20 as 2 times 10. Now, even though 20 can be written in a lot of different ways, just remember we're looking to get it into either the log 2 or the log 3. So that's why we write it as 2 times 10. Then I'm going to split it up using the product rule. Then I'm going to substitute. Now, keep in mind that, remember, when we have the same base and the same argument, the answer is 1 for a logarithm. That's why log base 10 of 10 is equal to 1. I simplify and I get 0.82. Same thing, feel free to pause. Okay, I'm starting the answer now. So remember, we need this in terms of either log 2 or log 3. So I'm going to write 5 as 10 over 2. Then I apply the quotient rule, split them in half, or not in half, into 2 pieces, a difference. Then I'm going to apply the fact that I have the same base and the same argument, and I'm going to substitute at the same time to get 1 minus 0.3, which is 0.7, our final answer. Okay, this is our last one of this particular type of example. Feel free to pause and restart. So for our final substitution problem, we start with a radical in the denominator. We have to change that to a negative rational exponent. Then I'm going to use the power rule to drop that negative exponent down in front as a coefficient. And finally, we can substitute our value of 0.3 in for log 2 before we simplify to get negative 0.1. So you can also use the properties of logarithms to solve equations using logs. You may need to change it to exponential form. So as a reminder, log base bn equals k if and only if b to the kth power equals n. It's also key to remember that the argument of a logarithm has to be positive. So once you get an answer, you have to go back and check it and make sure it's all good. So final example, we need to solve for x. So the first thing I'm going to do is I'm going to condense using the product property. So I get log base 3, x times x minus 6 equals 3. Then I'm going to change it to exponential form. It's 3 to the third power equals x times x minus 6. Then I'm going to solve. This is a simple quadratic. We use our zero product property, and we get x equals negative 3 and x equals 9. Now, I know that if I put negative 3 in, log 3 of x is undefined because that argument cannot be negative. So negative 3 goes, everything else checks out, and we're good. So that's all we have for today. Consider yourself an expert on the laws of logarithms. Now turn to your partner and tell them the 3 laws of logarithms that you learned today, and I will see you in the next video.